Hello all, this is a video review of the problems assigned in class on Wednesday, November 19th for the quiz, which is going to be Friday, November 21st. Question 15, the instructions for this sets of problems say that you're just supposed to analyze the system and solve for the blanks. In class, we discussed two really helpful strategies in solving for unknowns and analyzing the entire system. So the first is to do a free body diagram. So the free body diagram is actually already done for you here, so you don't need to add another one, but you do need to look at it and interpret what it means. In this one, there's two forces that are at angles to your coordinate system. So if the coordinate system is up and down is the y system, and left and right is the x system, then any components that go up and down are the y components, and any components that go side to side are the x components. So after you have figured out what the components are, you have to analyze each dimension separately because the y dimension cannot affect the x dimension. Those two are independent. So the first thing to do is to determine the acceleration of the system in each dimension. And it says that the acceleration of the system overall is just 0. So you know the accelerations for both are 0. And if the accelerations are 0, then the sum of the forces have to be 0. Because Newton's second law says F net is the description of two different things. It is the mass times the acceleration, and it is the sum of all of the forces. So you have to look at the forces acting in each dimension. And so in the x dimension, it's really just the x force of the tension from this one and the x force of the tension from this one. Those two have to add together to be 0, and they're going to cancel out. We actually don't even need the x component at all for this problem. However, you do need to know the y component. Now, all of the forces that act in the y dimension are Ft1 in the y and Ft2 in the y and the force of gravity. The force of gravity can be calculated. There actually is an equation for it. It is m times g. So the mass of the system is 80, and it says, here I'll use a different color. It says at the beginning of all of these problems that you can say g is 10. So we're going to use a g of 10 newtons per kilogram. And so if you have m of 80 equals 80 kilograms times 10 newtons per kilogram, the weight for this object is 800 newtons. So this number is given, and it's down. So we can even say it's a negative 800 because it's oriented down. Now these other two forces, they look identical. This angle is 120, so the angle between the horizontal and the pull is the same for both. This would have to be 30, and this would have to be 30. So the forces from these two have to be equal, which means the components from these two have to be equal. And so the force of tension in the y plus of tension 1 plus the force of tension 2 in the y have to add together to be 800. Because if you have a negative 800 here, the two numbers that are being added together are x plus y plus negative 800 equals 0. So you can solve for Ft1y and Ft2y to be 400 each. So each of those has to be 400. So there, this one is 400, and that's 400 up. And this one is 400. And that was 400 up. So 400 up plus 400 up plus a negative 800 down equals 0. Once you've figured out what the y component is, and you know the angle, then you can use trig to put the ratio of the angle to the opposite side divided by the hypotenuse. So the function to use for this one is the sine. So the sine of 30 degrees is the Ft2y divided by Ft2. And if you do that, Ft2y, we already said was 400. And the sine of 30 degrees is 0.5. So Ft2 has to be 800 newtons. if you do this math on your calculator, 400 divided by 0.5 is the same as saying 400 times 2. So if you do this math, you get the number 800, and it should make sense that 800 pulled this way, and then 120 degrees later, 800 pulled down, and then 120 degrees later, 800 pulled in that direction, and then 120 degrees later, and you're back to your original pull. The equal pull at equal angles should all cancel out. So in this case, it makes sense that the FT2 should be 800, and the FT1 should also be 800. The second question assigned is question number 16, and so it's in the same set of problems, which just asks you to analyze the system and solve for the blanks. So the free body diagram is, again, it's already done for you, so you don't need to do it again, so we'll just say that that's done. And then in the table that we use to help us analyze, it tells us that there's going to be an acceleration this time, and it's accelerating to the right. So the system that exists is this box is on Earth and resting on a surface. So there's a weight down. It tells us that there is friction, and here's the coefficient. And it's evident that there is a normal force because it's on a surface. And it says that there's a pull from some type of rope or something. So the tension is 60 newtons at 30 degrees. All of those things are the things that are given. The mass of the box is also given. So if you're pulling the system and it's going to accelerate to the right, then you know that your acceleration is greater than 0. So we can't say more than that, but we do know we now need to add these two forces together to equal m times a. If it's accelerating to the right, that means it's not accelerating up or down. So in the y dimension, you can say that the acceleration is 0. So when you look at all of the forces acting on this object, one of the things to do is to take this force and break it into components. So this one says Ft y, and then I did orange, so Ft in the x. Those are the two pieces. So you can think about those as the parts that have to get added to the force table. So in the y dimension, you got gravity down, you got the normal force up, and you got Fty that's also oriented up. Because you know the acceleration is 0, the sum of the forces has to equal 0. And so if there are things that you can calculate, then you should calculate them. Weight can be calculated. The mass is given. You know g. So the weight, the force of gravity, is 80 newtons down, because it's 8 times 10. So this is 80 newtons. The Ft and the y can be determined because you know this pull force and you know the angle. So again, here's the setup we're using. The pull is 60 newtons. This angle is 30 degrees. So the trig function that relates this side and the pull on the tension is the sine function. The sine of this angle is the opposite divided by the hypotenuse. So if you do the calculation on your calculator, you know that the sine of 30 is half. So Ft is 60 times the sine of 30. So 60 times half is 30 newtons. So the tension in the y direction, that's this one, is 30 newtons. And you know from your equilibrium statement about forces, if the force is 80 newtons down plus the normal force plus 30 newtons up, that means that the normal force has to be 50 newtons up plus 50 newtons. So that's where this number comes in. So the normal force, 50 newtons. That's all of the forces in the y dimension. We calculated weight already. We calculated the y component of tension. And the remaining force, to make it all equal to 0, needed to be 50 newtons. After you get all three of these forces, then you can begin working on some of the x components, specifically friction. So friction has an equation also. The force of friction is the coefficient of friction times the normal force. So you actually do need the normal force from the problem before in your friction equation. and the coefficient was given. So half of 50 is 25 newtons. So you can take that number and you can add it. To your diagram up here. So this is 25 newtons. And then the last question is to figure out the Ft in the x direction. And it's the same little triangle. So this component is the x component. And if this is the angle you're talking about, this side becomes the adjacent. So in order to solve for Ftx, you need to use the cosine. The cosine of the angle is the adjacent divided by the hypotenuse. And so if you add 60 newtons for Ft, you can say 60 times the cosine of the angle equals Ftx. So that number is given also. So the Ft in the x is 52. There's no blank for that spot. It doesn't ask us to solve for Ftx, but you need to use Ftx to determine the mass times the acceleration. So because the friction is 25 newtons to the left, and the Ftx is 52 newtons to the right, that is the sum of the forces, which is 27 newtons. Now it is equal to the mass times the acceleration. So if you want to solve for the acceleration all by itself, you take 27 newtons and you divide it by 8 kilograms. That gives a final answer of 3.4 meters per second squared. So this one can go here. 3.4 meters per second. And the net force is the number we solved. I guess I can use, oh boy, so many colors. This part right here is the net force, which means that it is 27 newtons to the right. To the right. That's all of them. That's all of the blanks for this problem. Question 23 asks you to use a graph here to determine the acceleration. And the question I would ask if you were in class is, which part of a velocity versus time graph tells you something about the acceleration? Hopefully you remember that the acceleration is the slope of a velocity versus time graph. And this slope goes up 2 meters per second in 16 seconds. So that's a slope of 0.125 meters per second squared. Okay? It's asking for this force. It doesn't give it to you, but it asks you to calculate this force. So the free body diagram that should be done, I know it's like sort of done here, but it is, I think, helpful to make it very clear that this is the object. It's pulled at that force at that angle, and there's gravity down and the normal up. There's a couple other arrows from the diagram that don't need to be on there. We don't need an arrow to indicate that it's frictionless. We just don't write friction. But because there's a force at an angle, you should split it into components. So this component, the Fpy, and this component is the Fpx. They can be used to determine the net force. So the acceleration was calculated, and this is going to accelerate sideways. It will not accelerate up and down. When you pull something, it accelerates in the horizontal direction. So the acceleration in the x can be determined. It doesn't accelerate in the y. And really the only force causing the acceleration is the Fp in the x direction. So the net force, Fpx, equals mass times acceleration. The mass is given. The acceleration was known. So the Fp in the x direction is 0.25 newtons. The question asks for the applied force. So you can use the Fpx and the angle to determine the Fp, because the cosine is the adjacent divided by the hypotenuse. And so if you need to solve for Fp, the hypotenuse, you just cross multiply. So Fp equals the adjacent divided by the cosine of the angle. And if you solve for Fp, if you do this math on your calculator, this is the number you should end with. So that's the end. We don't very often use tangent. If the question had asked you to solve for normal force, then you could use the tangent to determine the Fp in the y dimension, because you know the angle and you know the adjacent. So that's an extension that you could be asked to do. The last question is a little bit tricky with how to set up the free body diagram. Now this one says that this is it asks for the tension force. What is the force from each cable? And there's two cables here. There's this one, I call this cable 1, and this one, cable 2. And if you think about the forces being applied on the center of the mass, cable 2 actually is pulling this one this way, and cable 1 is actually pulling this way. So it's a little bit counterintuitive, but if you arrange it this way, then you are able to perform the analysis that you need to get to these individual components. Okay, so the free body diagram for this scenario looks like this, which means it asks you to calculate this force, like how hard is it pulling. Okay, in our little table that we use, the acceleration values are 0, so they should all be canceling out somehow. Now the ft and 2 in the x would have to be equal to ft2 in the y. Nope, ft1x would have to be equal to ft2x. So we don't actually need anything there. We can just use ft1y or ft2y to determine the hypotenuse, or the ft. Because you know that the force down is the force of gravity acting on this 10 kilogram sign. So 10 times 10, we can use 10 for this number, is 100. So the force down is 100 newtons. And these two forces are the same. The angles are the same. So if the angles are the same and the magnitudes look like they're the same, then, these should both be 50. I don't know why I have a negative. They should both be positive 50. So 50 up, 100 down gives you a net force of 0. So if you know that this is 50 from this analysis, then you know the angle, which was given. The sine is the trig function that relates this angle to this side and this side. So the sine of 60 degrees is the y component divided by the force of tension. Now we got to get ft all by itself, so this multiplies over here, divided by sine of theta. In this case, you take ft1y, which we said was 50. So this one is 50. 50 newtons divided by the sine of 60 degrees. I think that's like 0.866 or something like that. And if you do this math on a calculator, you get this number as the force of tension. And there are two of them. So this one is pulled with 58 newtons that way, and this one is pulled with 58 newtons that way. So those are the 4 sample problems we hoped you finished in class. Good luck preparing for your quiz, and if you have questions, you can come see me on Thursday.